All right, good morning, everybody. So on this problem, we are going to be using 4 rectangles to approximate the area under this curve. So not a quadratic this time, just another polynomial function. Between x equals -1 and x equals 3, that is another way of expressing the interval that we are going to find the area under the curve for. So folks, on this problem, we are going to be finding both LRAM and RRAM. And we're going to start with LRAM first. Now, just to kind of get a bit more into detail on how you go about drawing LRAM, I'd like you to write the following. First, you start at the left point, draw the rectangle, height to the next interval, and color down. So if we want to draw the LRAM here, first we're going to go back up to those other 2 steps that we outlined above, breaking up the interval using the number of rectangles. So let's go ahead and first look at our interval on this graph. It goes from -1 to 3. So I'm going to go ahead and label -1 and 0 and 1 and 2 and 3. Now again, ideally, we would like to draw a rectangle so that each one has a base that's 1 unit long. So if I were to just go 1 tick mark at a time, we would be able to make 1, 2, 3, 4 rectangles. Awesome. So this one's nice because the base of each rectangle is going to be just 1 instead of this one where we had to break into subintervals and our base was 0.5. So this one should be a little bit easier. So next, we are going to draw the sides up to our function and put dots where it touches the function itself. So we're going to go ahead and go to each of those interval tick marks. And again, we're not going all the way to the left. We're not going all the way to the right. Our interval starts at -1. So we are going to draw up and put a dot where it hits the function. We are going to draw a dot where it hits the function there, draw up, and draw up. Perfect. So again, this is how we outline each of these problems, whether we're doing the LRAM or the RRAM. You're always going to want to start with breaking up the interval and making the dots on the function. So following our new instructions for drawing the LRAM, first we are going to start at the left point, which would be this one here, draw a rectangle, and then color down. Then we go up to our next point on the next interval, make our rectangle height, and color down at the next interval. Next point, draw our height, color down, draw our height, color down, and we see that we had made our 4 rectangles. So now, to find the area of each of these rectangles, we need to take base times height, or we can do what we did above, which was the base times the sum of all the heights. Now, I warned in this problem that a lot of times students will forget about the 0.5 that's out in front when they go to do that final calculation. So just be careful, and if you're worried about making that mistake, you can go ahead and take each of the bases times each of the heights. So on this problem, our base is 1, and the height of each of these rectangles is going to come from the function itself. So that was given to us in that first step. F of x equals x cubed minus 4x squared plus 11. So we're going to be using this on our calculator. And you can either use the trace button or the table to figure out what each of those exact point heights are. And again, folks, on the My Math Lab, you'll be doing some estimating. Given a graph, like if you aren't given the equation that describes it exactly, but if you are given the equation, then we want to find those exact heights. So let's go ahead and type this into our y equals. So x cubed minus 4x squared plus 11. There's our curve. And let's go ahead and first draw or write out in general what each of those bases and what each of those heights will be. So our base for every single one of these is going to be 1. So we are going to multiply that by the height of the first rectangle. So the height of this rectangle comes from this point, which would be f of -1 on the function. And folks, as part of your work on the homework, I would like you to write it out using this function notation first before you start plugging in values. But you can either do base times height or base times the sum of all the heights. So 1 times f of -1 plus the base times our next height. Our next height comes from this dot, which would be f of 0 on our function. Then our base times our next height. This height of this rectangle, and I got a little sloppy with the coloring there, this would be f of 1. And then plus 1 times f of 2. So notice on this one, we're not doing f of 3 because that point is not the height of any of these rectangles. And as you start doing more of these, what you're going to notice is that LRAM always leaves off the right end interval number, and RRAM always leaves off the left end interval number as far as using it in your function to evaluate those heights. So now that we have all that lovely work shown, we now want to find f of -1, f of 0, f of 1, and f of 2 exactly. Now, because these are all nice whole numbers, I'm going to go ahead and go to the table. And from the previous problem, if you change your table settings, you may want to change that back from 0.5 to 1. And now I can see that 1 times f of -1 would be 6. And then plus 1 times f of 0, that would be 11. 1 times f of 1 would be 8. 1 times f of 2 would be 3. So to find each of these values, we plugged it in to our calculator. And if you wanted to, instead of using the table, you could just straight up plug in all of these values into the equation. -1 cubed, -1 squared, and then plus the 11. But something to be careful of is having to use your parentheses with all those expressions, which is why using your trace or your table is a little bit easier. So adding those values together, we find that our LRAM is equal to 28 what? Units squared. Because remember, we are finding area when we are looking at LRAM and RRAM. So make sure you've got that unit squared as your appropriate area unit. Alrighty, folks. So just by looking at what we found and how these rectangles measure the area under the curve, would you say that this is an overestimate or an underestimate of our actual area? As I'm kind of looking at these rectangles and I'm looking at this area over here, it looks like maybe this kind of triangle portion and this triangle portion might kind of fill in this area over here, but then we have that other little function piece or that other piece hanging over the function down at the bottom. So I would just say that LRAM is probably an overestimate of the actual area under the curve. And again, that's not something that you have to do on the homework, but it's not a bad idea to keep in mind to see, well, is that reasonable and what would our best estimate actually be? All right, folks, so that is how we draw LRAM. That is how we calculate LRAM. So now we are ready to find RRAM. Now, RRAM is going to be the exact opposite of how we found the LRAM. Instead of starting at the left point, we are going to start at the right point. So start at right point, draw the rectangle height, to the next interval, and color down. And again, these two problems where we're doing LRAM and RRAM on the same graph, it does get a little bit messy as far as our work and what all those rectangles look like. So don't be afraid on these ones if your graphs do look a little bit messy, because on the problems on the next page and the page after that, we will only be doing one per problem. So when we go to draw RRAM, here we are going to start at the rightmost point, which would be this one right here. So this point becomes our first rectangle height. I'm going to go ahead and color down because we have hit the next interval. Then this point becomes our rectangle height. Color down. This next point is our rectangle height. And then this point way up here is our rectangle height. All right, I'm going to just make this one a little bit more obvious there. All right, so just from looking at this one, I would say that this is probably an underestimate of the actual area. We can see I'm just a little bit over there, but I am under the curve here. There's this whole pink section that I'm not calculating the area of. There's this whole pink section I'm not calculating the area of. So maybe this part of the blue rectangle hanging over would displace this part, but RRAM for this problem would likely be an underestimate of the actual area. So LRAM here is over, RRAM here is under, and yes, that does happen to be the same as it was on the last problem. That's just a coincidence. It really depends on what your graph looks like and what your interval looks like. All right, folks, so now we are going to take the base of each of those rectangles, which each of those bases is 1, they will always be the same, times each of the heights. So our base is 1. The height of this first rectangle comes from this point, which would be f of 0. The height of this rectangle comes from this point, which would be f of 1. The height of this rectangle comes from this point, which would be f of 2. And then lastly, the height of this rectangle would be f of 3. So base times the height. All right, and some of these values we already have from the previous problem, but again, using our calculator, f of 0 would be 11. Let's see, f of 1 is 8. F of 2 is 3. And f of 3 is 2. So notice on this one, I included f of 3, the end interval, and on this one, I included f of -1, the end interval. So one of those is always going to get left off. That's one of the more common mistakes is students will try to use all of those interval points, but depending on whether you're doing LRAM or RRAM, one of those endpoints does get not included. So adding these all up, we would get the RRAM is equal to 24 what? Units squared. So again, if I wanted to find the best estimate for this area under the curve, we would take the average of these, so LRAM plus RRAM divided by 2. So 28 plus 24 divided by 2, which would be 26 units squared. And again, it's still an estimate, but this would be our best estimate of the actual area under the curve. And in the next video, we'll go ahead and take a look at the problems on the next page.